Hello and welcome to the Arduino section. Today we will learn about what an Arduino is, why we should use it, and how we should use it. Well, Arduino is an open source electronics platform that combines hardware and software in a beginner-friendly package. At its foundation is the Arduino board, a computer with a programmable microprocessor that comes in a variety of shapes and sizes. We will be using the original board, the Arduino Uno, as shown here. The Arduino Uno is nice in that because it has female headers, we can use male-headed wires to easily create and break electrical connections to things like sensors and motors without needing to solder. In addition, there are many open source code libraries you can download to use and control sensors, motors, and more. As a result, they are great for electromechanical projects. Let's dig into two examples. The first is a research project where I was contracted by a Bloomberg School of Public Health researcher that wanted to conduct animal exposure studies with e-cigarette aerosols. However, they also wanted to use multiple exposure chambers and therefore multiple e-cigarettes at the same time. They tasked me to create an actuator that could simultaneously activate 4 e-cigarette devices, and I delivered what you see below. The design is a combination of off-the-shelf components, 3D printed pieces, and electronics controlled by the Arduino Uno, including a separate motor to push the buttons and the OLED display to show the number of presses. The next example is from one of my courses, where a team and I wanted to design a solution for low mobility patients who need to be frequently turned to avoid the development of pressure injuries. We created a chest-worn device that could track the angle at which the patient was turned, lighting up LEDs until the ideal angle is reached, and that could communicate with an app through Bluetooth to provide instructions and reminders to turn. For this project, we used an Arduino Circuit Playground, a circular board shown here, with onboard LEDs and Bluetooth that perfectly fit our needs. For both of these projects, the electronics were quick to implement thanks to Arduino. Now, let's take a tour. So starting at the corner, we can see a barrel jack for powering the board. You can either use a wall plug or a battery jack adapters to power the board. Next up, we have a USB Type-B port, which we will use to connect to our board to the computer to upload code and communicate with the Arduino. When you connect this cable to the computer, your computer will also power the Arduino board. In this corner, we have the reset button, which will restart your program from the beginning. Along the sides, we have 14 digital input-output pins, which can be used to send binary signals to sensors and to read binary signals from sensors. Binary sensors have two states, like yes or no, and can be helpful for simple sensors like button presses. On the other side, we have 6 analog input pins, which can receive continuous signals. For a sensor such as a photoresistor that can measure brightness, we would not want a simple binary signal, but rather a continuous gradient of signals. Above those, we have the power and ground pins. For power, we have a 3.3 volt pin, a 5 volt pin, and a V-in pin that provides direct power from whatever power input source you're using. In addition, we also have 3 ground pins total, 2 on the left and 1 on the right. To connect your computer to the Arduino, you will need the Arduino Integrated Development Software. So the program is available at the website shown here, and it can run on macOS, Windows, and Linux. Once you install the program, we can start writing Arduino programs called sketches. Notice how the sketch is automatically set up in 2 different sections, a setup section and a loop section. The setup section is for the code that will run once when a program starts, and the code in the loop section will run and endlessly repeat after the setup code runs. To upload your code to the Arduino, plug the USB Type-B cable from the Arduino Uno into your computer. You can check that the board is recognized by your computer by going to the Tools menu and checking to see if the board is associated with the port. Once you check that it's connected, you can use the checkbox here to verify your code, and then you can use the arrow button here to upload your code. After that, your code should be uploaded and your program should begin running on your Arduino. Thank you.